So, no such thing as the chain rule. It's just a heading. It's a technique. There's no rules about it, but it follows a process. So the process goes like this. Look for the complicated bit. So kind of like yesterday with substitution, but this time it has a little bit around it. So what we're going to do with that complicated part is anti-differentiate it. Now that sounds like integration, we know it is. But by anti-differentiating it, we're going to come up with anti-differentiate, that's enough letters. Then we're going to go backwards. We're going to differentiate it, right? So we're going to anti-differentiate it, we're going to differentiate it, and then we're going to compensate. We're going to look at it, I'm going to say, okay, we didn't get back to where we started, so what do we need to do for it to look like what we started with? All right? So what sort of questions would you have to do this to? Let's say, let's look at an easy-ish one. All right. So the complicated part obviously is not the 8x. So the complicated part, first of all, is the x squared plus 4 to the power of 3. Where did it come from? It came from x squared plus 4 to the power of 4. All right, we take the power, we multiply by it, da, 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 da. We do lots of other things. But that's where it came from. So if we differentiate this, what do we get? We get 4x squared plus 4 to the power of 3 times 2x. Right? So 4 and 2x, 8x. Now we compare that to the beginning. It's the same thing. So it came from that. So this integrates to this. Right? Okay, now not such an easy one. Oh, I must have been reading my mind. 4x e to the x squared plus 1 dx. I feel like I've heard that e to the x squared before today. All right, so what have we got here? Okay, well, the complicated part is e to the x squared plus 1. So, what did that come from? When we differentiate x squared, e's, it comes from itself. So we're going to say, okay, it came from this, approximately. Happy with that? Okay, so if we differentiate that, what do we get? We get e to the x squared times 2x plus 1. Yes? Compare. What's different? So our compensate, we didn't get enough. We didn't get enough to get back to where we started. We need a bit more. Oh, that's interesting. I've done this completely differently. Hokey pokey. That's going to be an interesting one. We'll just keep going and see what happens. I don't know what's going to happen. So we need there a 4. I want to go back and do it how it's supposed to be done. Okay, so we're going to have to times it by 2. What does that give us? That gives us 4e to the x squared plus 2. Right, so if we differentiate that, we get that, don't we? Right, because that's 2 times x is 2. So it still doesn't match up with that because of that 2, because it wasn't supposed to be in my question. We're just going to get rid of it and go back to that. Yeah, well, it was supposed to be in the air. I didn't read my notes very well. So it was supposed to be up here. So that wasn't even there. So if we differentiate that, we get that. Oh, God, I don't know. I'm lost now. Completely lost in what I'm doing. Yeah, sure, it should still be there. All right, so we just changed the question. Goody goody, we love changing the question halfway through. So if it was up in the air where it was supposed to be, we would have gone through this process, got to the 2x, compensated by multiplying by 2. So that means we're multiplying this step here, our guess, by 2. So our second step is our guess. Right? That's what we ended up with. Our second step is our guess, so therefore we're going to say that this is 2 of these. We're not. Right, so that's where we'll end up. Happy? Okay, sorry about that.